September 1942. Stalingrad. The rubble-choked streets of the Soviet industrial city had become a graveyard for German ambitions. Wehrmacht soldiers, accustomed to sweeping victories across open terrain, found themselves trapped in a nightmare of urban warfare. Every building was a fortress, every window concealed a sniper, every cellar hid defenders willing to fight to the last bullet. The German army's artillery and conventional tanks, designed for battles across the fields of France or the steppes of Russia, were nearly useless in this environment. Buildings absorbed shell fire that would have destroyed field fortifications. The 15-centimetre infantry guns mounted on converted tank chassis could damage structures, but rarely with a single shot. What the Wehrmacht needed, what their commanders desperately requested, was a weapon capable of demolishing an entire fortified building with one round. They needed overwhelming firepower delivered with surgical precision. What they got, 2 years too late to matter, was the Sturmtiger, one of the most extreme weapons ever conceived for armoured warfare. A vehicle that married a Tiger tank to a naval rocket launcher designed to hunt submarines. A machine that fired projectiles the size of torpedoes. The Sturmtiger represented German engineering at its most audacious and most desperate, a weapon so powerful it could level a city block, yet so specialised it arrived when Germany needed quantity, not quality. Only 18 would ever be built. By the time they reached the battlefield, Germany was fighting for survival, not conquest. But those 18 vehicles would demonstrate a level of destructive capability that shocked everyone who witnessed it, friend and enemy alike. The genesis of the Sturmtiger lay in the smoking ruins of Stalingrad, where the German Sixth Army discovered that their technological superiority meant nothing in an environment where a squad with rifles and grenades could hold an apartment building against an entire company. The existing urban assault vehicles were inadequate. The Sturminfanteriegeschütz 33B, a Sturmgeschütz III mounting a 15-centimetre heavy infantry gun, could damage buildings but not reliably destroy them. 12 of these vehicles were lost at Stalingrad, either to enemy action or abandoned when they couldn't navigate the debris-choked streets. The Wehrmacht needed something heavier, more powerful, more survivable. Initial designs called for mounting a 210mm howitzer on a heavy tank chassis. This would have provided substantial firepower, equivalent to the heaviest German field artillery. But in 1943, as the project moved forward, engineers at Alket, the Berlin-based armoured vehicle manufacturer, faced a problem. The 210mm howitzer wasn't available in sufficient quantities. Production was prioritised for towed artillery, and adapting the weapon for a tank mounting would take time Germany didn't have. Someone at Alket had an idea that seemed almost absurd. The Kriegsmarine, Germany's navy, had been developing a rocket-propelled depth-charge launcher for coastal defence, designed to engage submarines from shore positions. The weapon, designated Raketenwerfer 61, fired a 380mm projectile, essentially a depth charge with a rocket motor. It was massive, crude, and designed for a completely different purpose. But it was available. The idea of putting a submarine weapon on a tank seemed preposterous. The RW-61 was intended to lob depth charges at underwater targets at relatively short ranges. It had never been conceived as an anti-fortification weapon. But the more engineers studied it, the more sense it made. The 380mm caliber was enormous, larger than any other tank-mounted weapon in existence. The rocket propulsion meant it could be fired from a short barrel without losing range or accuracy. The warhead could be modified to carry high explosives or shaped charges specifically designed to penetrate reinforced concrete. Most importantly, it existed. In August 1943, after reviewing the proposal, Adolf Hitler personally ordered the project forward. The weapon would be mounted on the chassis of the Tiger I tank, the only platform sturdy enough to handle the massive rocket launcher and its ammunition. The official designation would be Sturmmörserwagen 6064 MIT 38 cm 61. Everyone simply called it Sturmtiger, Assault Tiger. The engineering challenge was immense. The Tiger I chassis, already one of the most complex armoured vehicles in the world, had to be completely modified. The entire front superstructure of the Tiger was removed and replaced with a fixed, box-like casemate designed to house the rocket launcher and its 5-man crew. The transformation was dramatic. Where the Tiger stretched over 8 meters in length, much of that from its long 88mm gun protruding from the front, The Sturmtiger was just 6.28 meters long. The shortened profile came from the RW-61 stubby barrel, just 2 meters long. It looked almost comically short compared to conventional tank guns. This short, blunt weapon gave the Sturmtiger an appearance unlike any other armoured vehicle. It looked less like a tank and more like a mobile bunker, with a massive pipe sticking out the front. The weapon itself was a marvel of adaptation. The naval RW-61 had to be completely redesigned for land use. The original depth-charge launcher operated at relatively low pressures and was designed to fire into water. Adapting it to fire high explosive and shaped charge projectiles against land targets required solving several engineering problems. The most significant was venting the rocket exhaust. Unlike conventional guns, where propellant gases are vented through the barrel after the projectile exits, rocket-propelled projectiles continue burning as they fly. The rocket motor inside each projectile generated tremendous heat and pressure. If these gases were vented into the fighting compartment, they would incinerate the crew. If they weren't vented at all, the pressure would rupture the barrel. The solution was ingenious and gave the Sturmtiger its most distinctive feature. Engineers surrounded the barrel with a series of ventilation shafts that channeled the exhaust gases forward and expelled them through a ring of holes around the muzzle. Different Sturmtigers had different numbers of these exhaust ports, with vehicles observed having 20, 30 or 31 shafts. This arrangement gave the weapon a distinctive pepperbox appearance, unlike any other gun in existence. When fired, the rocket exhaust would blast out of these ports in a spectacular display, creating a corona of flame around the muzzle that could be seen from kilometers away. The ammunition was as impressive as the weapon. Each projectile measured 1.5 meters long, nearly 5 feet, and weighed between 345 and 376 kilograms, roughly 760 to 830 pounds. To put this in perspective, each round was heavier than an American 500-pound bomb and about the same size. These were not shells in the conventional sense. They were rocket-propelled missiles, each containing its own propulsion system. The projectile consisted of several components. At the front was the warhead, either a high explosive charge or a shaped charge depending on the mission. Behind this was the rocket motor, the Triebsatz 40-1, containing approximately 40 kilograms of solid propellant. At the base were 32 exhaust nozzles arranged in a circular pattern. When fired, a conventional propellant charge first accelerated the projectile to approximately 45 meters per second as it left the barrel. Then the rocket motor ignited, boosting the velocity to around 250 meters per second, roughly 560 miles per hour. This gave the projectile a maximum range of approximately 5,150 meters, over 3 miles, though effective range was considerably less. 2 types of ammunition were produced. The Raketen Sprenggranate 4581 contained a 125 kilogram high explosive charge, designed for general demolition work against buildings and field fortifications. This warhead was powerful enough to collapse a multi-story building with a direct hit. The blast effect alone could kill unprotected infantry within a 30-meter radius. The second type, the Raketenhohlladungsgranat 452, used a shaped charge warhead specifically designed to penetrate reinforced concrete. The shaped charge could punch through up to 2.5 meters, over 8 feet, of steel-reinforced concrete, making it capable of defeating even the strongest bunkers and fortifications. Only 317 of these projectiles reached German forces before the war ended, a testament to how limited production was. Loading these massive projectiles was a challenge that required the entire crew's participation. Each Sturmtiger carried 14 rounds internally. One was already loaded in the breech, ready to fire. Another sat on the loading tray, prepared for quick loading. The remaining 12 were stored in racks along the interior walls of the casemate. Despite the seemingly spacious interior, these massive rounds filled almost every available space. The loading process was elaborate and time-consuming. When the vehicle needed to be resupplied, a small crane was erected on the rear of the superstructure. This crane lifted each projectile through a large rectangular hatch in the roof and lowered it into the fighting compartment, where the crew would manhandle it into the storage racks. Even with the crane, loading was exhausting work. Each projectile weighed as much as 2 men. Handling them in the confined space of the fighting compartment required careful coordination. Inside the vehicle, moving a projectile from storage to the firing position used a loading tray fitted with rollers. Two crew members would extract a round from its rack, place it on the tray, and roll it into position behind the breech. Even this internal loading could take several minutes. The gunner and loader had to work in precise synchronization, as the projectile's length and weight made any mistake potentially disastrous. The vehicle itself was built to survive. Urban combat was expected to be brutal, with threats coming from all directions and ranges. The Sturmtiger needed armour that could withstand direct hits from anti-tank weapons and artillery. The frontal armour was 150mm thick, angled at 47 degrees from vertical. This effective thickness exceeded 200mm, making it nearly impervious to most Allied anti-tank guns of the period. Soviet 122mm and 152mm artillery shells, which could destroy most German tanks, had difficulty penetrating this armour. The superstructure sides and rear were 82mm thick, still substantial protection against most threats. The lower hull retained the Tiger I's original armour, 100mm at the front, with an optional additional 50mm plate that some vehicles received, bringing total frontal protection to 150mm. This armour came at a cost. The Sturmtiger weighed approximately 68 tons, compared to the Tiger I's 57 tons. This 11-ton increase put enormous strain on the powertrain. The engine remained the same as the Tiger I, a Maybach HL230 P45, a V12 liquid-cooled engine producing approximately 700 horsepower. On the Tiger I, this engine provided adequate if not impressive performance. On the Sturmtiger, with its additional weight, performance suffered. Top speed on roads was limited to approximately 40 km per hour, about 25 miles per hour. Cross-country speed was even lower. The power-to-weight ratio dropped to around 10 horsepower per ton, making the Sturmtiger one of the slowest and least manoeuvrable heavy-armoured vehicles in German service. Range was equally problematic. The Sturmtiger consumed approximately 2 gallons of fuel per mile, or nearly 1,000 litres per 100 kilometres. With Germany's fuel supplies critically short by 1944, this thirst for gasoline severely limited the vehicle's operational deployment. Secondary armament was minimal. A single MG-34 machine gun was mounted in a ball mount on the front plate, operated by the radio operator. This provided some defence against infantry, but the limited traverse and elevation made it of questionable utility. More unusual was the Nahverteidigungswaffe, or close defence weapon, mounted at the rear of the vehicle. This was a 90mm launcher that fired special grenades designed to explode in mid-air, showering attacking infantry with shrapnel. The system could rotate 360 degrees, providing all-around defence against close assault. The weapon launched bouncing mines that would leap several metres into the air before detonating, creating a lethal fragmentation pattern. This was particularly useful in urban environments where infantry could approach from unexpected angles. The crew consisted of 5 men, a commander, gunner, loader, driver, and radio operator, though loading the main weapon often required all hands. The commander occupied a position with limited visibility, a significant problem for a vehicle designed for urban combat, where situational awareness was critical. Vision devices were minimal. The gunner used a Kugeloptik Zef 3x8 sight for aiming the main weapon, but this provided only a narrow field of view. The vehicle also had pistol ports on both sides, ostensibly for crew members to fire personal weapons, but these served more usefully as additional vision ports. The fighting compartment was relatively spacious compared to most German armoured vehicles, necessary given the size of the ammunition being handled. But the space was illusory. With 14 massive projectiles stored internally, along with the loading mechanism, crew stations and equipment, there was barely room to move. The environment was cramped, hot, and filled with the smell of propellant and rocket fuel. Production began in early 1944, far too late to fulfill the weapon's original purpose of supporting offensive urban warfare. By this time, Germany was entirely on the defensive. Cities were being destroyed by Allied bombers, not captured by German infantry. The Sturmtiger was a weapon designed for an offensive war that had already been lost. Alket received contracts to convert Tiger Army chassis into Sturmtigers. Rather than building new vehicles from scratch, damaged Tiger tanks returning from the front were sent to the Alket plant in Berlin-Spandau for conversion. This made sense from a production standpoint. Many Tiger tanks returned from combat with damaged turrets or main guns, expensive components that were difficult to replace. By removing the turret entirely and mounting the Sturmtiger superstructure and weapon, These chassis could be returned to service relatively quickly. Each conversion took approximately 3 days, a remarkably short time given the extensive modifications required. The entire front of the Tiger had to be cut away and replaced with the new casemate structure. The weapon and its mounting had to be installed. The ventilation system for the rocket exhaust had to be fabricated and fitted. The loading crane and associated equipment had to be mounted. That all this could be accomplished in 72 hours speaks to both German manufacturing expertise and the pressure under which they were working. The first prototype was completed in October 1943 and presented to Adolf Hitler at the Arras training grounds in East Prussia. Hitler, always fascinated by massive weapons and super heavy equipment, was impressed. He ordered immediate production, demanding that at least 300 rounds of ammunition be manufactured monthly to support operations. This production target was wildly optimistic. Germany's industrial capacity was already stretched beyond limits, maintaining production of conventional tanks, aircraft and ammunition while under constant Allied bombing. Producing 300 rounds per month of specialized 380mm rocket projectiles was simply impossible. In reality, only 317 projectiles were manufactured during the weapon's entire production run. By February 1944, the first 3 production Sturmtigers were completed. Production continued sporadically through the year. 10 vehicles were completed in September 1944. Another 5 followed in December. In total, 18 Sturmtigers were built, plus the original prototype. This tiny production run meant the weapon could never have strategic impact. 19 vehicles, regardless of how powerful, could not change the course of a war, but they could, and did, create localized devastation wherever they appeared. 3 Panzersturmtiger armoured assault mortar companies were formed to operate these vehicles. Designated 1000, 1001 and 1002, each was originally planned to receive 14 Sturmtigers. This was quickly recognized as impossible given production realities. The allocation was reduced to 4 vehicles per company, divided into 2 platoons of 2 vehicles each. Even this reduced strength was difficult to maintain. Mechanical reliability was poor, ammunition was scarce, and fuel consumption was enormous. Keeping even a handful of Sturmtigers operational required substantial logistical support that Germany's crumbling infrastructure could barely provide. Sturmwasser Company 1000 was the first unit formed, activated on August 13, 1944. Within days, it received its baptism of fire in circumstances that were both tragic and futile. Warsaw was in revolt. The Polish Home Army, the resistance organization that had operated underground throughout the German occupation, launched an uprising on August 1, 1944, timed to coincide with the approaching Soviet army. The plan was for Polish forces to liberate their capital before the Soviets arrived, establishing Polish sovereignty and preventing Soviet occupation. The uprising caught German forces by surprise, but their response was swift and brutal. Wehrmacht and SS units were redirected to Warsaw with orders to crush the revolt completely. The German command recognized Warsaw's dense urban environment as ideal for testing their new assault gun. On August 15, 1944, the Sturmtiger prototype was unloaded at the railway station in Pruszków, a suburb of Warsaw. 3 days later, a second vehicle arrived. Sturmwasser Company 1000, with 2 operational Sturmtigers and the prototype operating separately, was committed to combat. The Sturmtigers were not deployed to the front lines where they risked falling into craters or being ambushed at close range. Instead, they were stationed in rear areas, around streets like Ulica Sucha and Ulica 6 Sierpnia in the Mokotów district, and possibly at Plac na Rozdrożu, Crossroads Square. From these positions, they could fire at extended ranges, demolishing resistant strongpoints from relative safety. The psychological impact of the 380mm projectiles was immediate and profound. Warsaw's defenders had experience with German artillery, mortars, and even the dreaded Nebelwerfer rocket launchers, nicknamed Screaming Mimes for their distinctive sound. But nothing prepared them for the Sturmtiger. The projectiles arrived with a rushing, roaring sound, followed by explosions that witnesses compared to aerial bombs or railway artillery. Buildings didn't just collapse. They disintegrated. A single hit could bring down an entire structure, burying defenders under tons of rubble. The blast radius was enormous. Unprotected personnel within 30 meters of the impact could be killed by overpressure alone. their internal organs liquefied by the shockwave. At the end of August, a Sturmtiger firing from the former ghetto area or Kasili Square pounded targets including Ulica Zakroczymska and the National Mint on Ulica Sanguska in Warsaw's Old Town. Each shot demolished buildings that had stood for centuries, erasing history with high explosives. Another vehicle shelled resistance positions in the suburb of Sadiba. Between September 8 and 16, Sturmtigers fired on the area around Ulica Przemysłowa, Ulica Fabryczna, and Ulica Nacna in the Pewyśla district. The difficulty in establishing precise details of Sturmtiger operations stems from the weapon being completely unknown to the Allies at this time. The massive explosions were often attributed to aerial bombs, railway gunfire, or even other rocket artillery. The Sturmtiger was an entirely new weapon system, and its existence wasn't confirmed until vehicles were captured in 1945. One unexploded projectile, discovered after the fighting, is still displayed at the Polish Army Museum in Warsaw, a testament to the weapon's deployment during the uprising. The Warsaw Uprising was crushed by October 2, 1944, after 63 days of fighting. The Polish Home Army, outgunned and abandoned by the nearby Soviet forces who cynically waited across the Vistula River while the Germans destroyed Poland's resistance movement, was forced to surrender. The city itself was systematically demolished on Hitler's orders, reduced to rubble as punishment for the uprising. The Sturmtigers had performed as designed. They demolished fortified buildings with single shots. They broke resistance strong points that conventional artillery had difficulty effecting. For once, a German superweapon had been used in precisely the role for which it was designed. On August 28, 1944, the prototype was returned to the Alket plant in Berlin-Spandau, possibly for repairs or modifications based on combat experience. The two other vehicles of Sturmörser Company 1000 remained operational, but their next deployment would be very different. December 1944. The Ardennes Forest in Belgium and Luxembourg. Hitler was planning Germany's last major offensive in the West, a desperate gamble to split the Allied armies, capture the port of Antwerp and force the Western Allies into a negotiated peace. The operation, codenamed Wacht am Rhein, Watch on the Rhine, would become known to history as the Battle of the Bulge. Sturmörser Company Hound and Royal One were assigned to participate in the offensive. The plan called for 7 Sturmtigers to support the assault. But plans rarely survive contact with reality, especially in late 1944 Germany. Transportation problems plagued the units. Moving 68-ton vehicles hundreds of kilometres to the Ardennes required specialised rail transport. Germany's railway system was under constant Allied air attack. Locomotives were priority targets for fighter bombers. Rail yards were bombed regularly. Getting the Sturmtigers to their assembly areas proved impossible. By the time the offensive launched on December 16, 1944, none of the Sturmtigers had reached their assigned positions. They would take no part in the initial assault. The Battle of the Bulge proceeded without them, but the Sturmtigers would see action in the west. After the Ardennes offensive stalled and was eventually pushed back, the vehicles were deployed in the defensive battles that followed. Sturmörser Company 1001 and 1002, along with elements of Company 1000, fought in various engagements as Allied forces pushed toward the Rhine River. The Sturmtigers proved to be excellent defensive weapons. Their massive firepower could break up Allied attacks, destroying buildings used as strong points and demoralizing attacking infantry. Their heavy armour made them difficult to destroy except by air attack or concentrated artillery fire. Most Sturmtigers lost during this period were abandoned by their crews due to mechanical breakdown or fuel shortage, not destroyed in combat. The low rate of combat losses testified to both the vehicle's survivability and Germany's inability to support them logistically. March 1945. Remagen, the Ludendorff Bridge. The unexpected capture of the last intact bridge across the Rhine River by American forces on March 7, 1945, sent shockwaves through German command. The Rhine was Germany's last major natural barrier. If the Americans could establish and expand a bridgehead on the eastern bank, they would have a clear path into Germany's industrial heartland. Hitler ordered everything available thrown at the bridge to destroy it. Artillery, airstrikes, floating mines, demolition swimmers, everything. Among the forces rushed to Remagen were Sturmörser Company 1000 and 1001, a total of 7 Sturmtigers. The plan was simple. Use the massive rocket launchers to bombard the bridge and the American positions around it, until the bridge was destroyed or the bridgehead eliminated. In practice, the Sturmtigers faced significant problems. The bridge was over 300 meters long and relatively narrow, a difficult target even at close range. The 380mm rockets, designed for demolishing large buildings, lacked the precision needed to hit a bridge with any consistency. The Sturmtigers were positioned near Düren and Euskirchen, several kilometers from Remagen, and began firing on the town and surrounding American positions. The projectiles caused significant damage to buildings in Remagen itself, but consistently missed the bridge. The massive explosions terrorized American troops and demolished structures throughout the town, but the bridge remained standing. Then, on one mission, a Sturmtiger from Sturmmercer Company 101 achieved what may be the weapon's most notable combat success, and certainly its only recorded tank-on-tank engagement. American armour had consolidated in a small village near the bridge. Several Sherman tanks were stationary, possibly refueling or conducting maintenance. The Sturmtiger crew spotted them and fired a single 380mm projectile into the village. The result was catastrophic. The rocket, designed to demolish buildings, struck near the grouped Shermans. The 125-kilogram high-explosive warhead detonated with a blast that could be felt kilometers away. Multiple Sherman tanks were destroyed or disabled. Crews were killed or wounded by the overpressure and fragmentation. Reports from German sources, never fully verified by American records, claimed nearly all the Shermans in the group were put out of action by this single shot. Whether the numbers were exaggerated or not, the incident demonstrated what a 380mm high-explosive warhead could do to armoured vehicles. Tanks were designed to resist armour-piercing rounds, not demolition charges equivalent to a 500-pound bomb detonating at close range. This remains the only confirmed instance of a Sturmtiger engaging enemy tanks in direct combat, an ironic footnote for a weapon never intended for anti-tank warfare. Despite the Sturmtigers and every other weapon Germany threw at the bridge, the American bridgehead expanded rapidly. Engineers constructed pontoon bridges alongside the Ludendorff Bridge, ensuring that even if the railway bridge was destroyed, troops and supplies could continue flowing across. On March 17, 1945, 10 days after its capture, the Ludendorff Bridge finally collapsed, weakened by the original German demolition attempt, subsequent German attacks, and the strain of heavy Allied traffic. 28 American engineers were killed when the structure gave way. But by then, it didn't matter. Over 125,000 American troops had crossed the Rhine. The door to Germany's heartland stood open. The Sturmtigers had failed in their mission. They were withdrawn from Remagen and used in various defensive actions as Allied forces pushed deeper into Germany. One by one, they were lost. Some broke down and were abandoned when their crews couldn't repair them or had no fuel to move them. Others were destroyed by air attacks, the one threat their heavy armour couldn't protect against. A few were simply left behind as German forces retreated, becoming prizes for advancing American and Soviet troops. The combat history of the Sturmtiger, brief as it was, revealed both the weapon's strengths and its fatal limitations. When used as designed, firing at large, stationary targets like buildings and fortifications, it was devastatingly effective. A single hit could achieve what conventional artillery needed multiple rounds to accomplish. The psychological impact on enemy forces was significant. Troops who had endured conventional artillery found the Sturmtiger's massive projectiles uniquely terrifying. But the weapon's limitations were equally clear. It was slow, consuming fuel at an enormous rate in a nation that had virtually no fuel to spare. It was mechanically complex and unreliable. The Tiger front chassis, always maintenance intensive, became even more problematic with the additional weight of the Sturmtiger conversion. Ammunition was impossibly scarce. With only 317 projectiles manufactured during the entire war, Sturmtiger crews had to use their ammunition sparingly. Each shot was precious, making the weapon unsuitable for sustained operations. The loading process was time-consuming. Even with a well-trained crew, reloading took several minutes per round. This made the Sturmtiger vulnerable during reload cycles and limited its rate of fire to just a few rounds per hour under combat conditions. Range was limited. While the maximum range was over 5 kilometers, effective range was much less. The rocket-propelled projectiles were inherently less accurate than conventional artillery shells. Hitting specific targets at long range was difficult or impossible. By April 1945, as Allied forces converged on Germany from east and west, The remaining Sturmtigers were scattered across the collapsing front. Some were encountered by American forces in the Ruhr Pocket, the surrounded industrial region that became the tomb of an entire German army group. Others were found abandoned in towns and villages, their crews having fled or surrendered. The Soviets captured at least one Sturmtiger in the final fighting around the Elbe River. This vehicle, chassis number 2553, would eventually be shipped to the Soviet Union and placed on display at the Kubinka Tank Museum, where it remains today. American forces captured several Sturmtigers intact. These vehicles became objects of intense interest to Allied intelligence and testing units. American soldiers, seeing the massive 380mm rocket launcher for the first time, were both impressed and bemused. Photographs from April 1945 show American GIs posing with captured Sturmtigers, some standing inside the enormous barrel, which was wide enough to admit a man. The images capture both the weapon's awesome scale and its ultimate futility. This monster, capable of demolishing buildings with single shots, had been built in numbers too small and arrived too late to affect anything. One captured Sturmtiger was shipped to Britain for evaluation. British experts tested the weapon and studied its design. After testing was complete, the vehicle was scrapped. Only the 380mm rocket launcher itself was preserved. It remains in the collection of the Tank Museum in Bovington, England, a strange artifact of German engineering extremism. A Sturmtiger on display at the Deutsches Panzermuseum in Munster, Germany, chassis number 255174, represents one of only two complete vehicles that survive today, along with the example at Kubinka. These are all that remain of the 19 vehicles built. The technical specifications tell the story of German engineering at its most extreme. Weight, 68 tons. Length, 6.28 meters. Width, 3.57 meters. Height, 2.85 meters. Armor, 150mm frontal, 82mm side and rear. Main armament, 38cm Raketenwerfer, 61L 5.4. Ammunition, 14 rounds of 380mm rocket-propelled projectiles. Engine, Maybach HAL 230 P45 V12, 700 horsepower. Maximum speed, 40 km per hour on roads. Range, approximately 120 km. Crew, 5. These numbers defined a vehicle that was simultaneously impressive and impractical, a weapon that represented the pinnacle of German heavy armour design and the nadir of German strategic thinking. Every aspect of the Sturmtiger's design emphasized maximum firepower and maximum protection. It was built to survive in the most hostile environment imaginable, urban combat at close range, and to deliver firepower that could change the tactical situation with a single shot. In this narrow mission profile, it succeeded. But success in a narrow mission means nothing when that mission is irrelevant to the strategic situation. By the time the Sturmtiger entered service, Germany didn't need super-heavy assault guns for urban combat. Germany needed hundreds of reliable medium tanks, thousands of trained crews, and millions of gallons of fuel. The Sturmtiger represented resources poured into a spectacular weapon system when Germany desperately needed ordinary weapons in extraordinary quantities. The projectiles themselves were engineering marvels that highlighted the same contradiction. Each 380mm rocket was a sophisticated weapon system, combining rocket propulsion with either high explosive or shaped charge warheads, packaged in a vehicle-launched format. The thin-walled construction of the projectiles, necessary because they were rocket-propelled rather than gun-launched, meant they couldn't withstand the acceleration forces of a conventional gun. This was why the naval 380mm gun couldn't fire them. They required the gentler acceleration of a rocket launcher. The rocket motor, using solid propellant, provided sustained thrust after the projectile left the barrel, maintaining velocity and extending range. The 32 exhaust nozzles at the base created a distinctive exhaust pattern that gave the projectile stability in flight. The warheads were tailored to specific missions. The high-explosive version was optimized for blast effect, designed to create maximum overpressure and fragmentation. The shaped charge version focused explosive energy into a narrow jet capable of penetrating massive thicknesses of reinforced concrete. This was cutting-edge military technology in 1944, but producing 317 of these projectiles consumed resources that could have manufactured thousands of conventional artillery shells or hundreds of anti-tank rounds. The cost-benefit analysis was damning. Every Sturmtiger projectile cost far more to produce than the damage it inflicted. Not because it wasn't destructive, but because Germany's strategic situation meant no amount of tactical destruction could change the outcome. The crews who operated these vehicles have left few detailed accounts, but the available records paint a picture of both pride in their weapon and frustration with its limitations. The Sturmtiger was prestigious. It was a unique, powerful system that garnered attention wherever it appeared. Crews knew they operated something special, but prestige doesn't compensate for mechanical breakdowns in the field, or for having no ammunition, or for being ordered to bombard a bridge with a weapon designed to demolish buildings. The physical demands of operating the vehicle were significant. Loading the 345 to 376 kilogram projectiles required all 5 crew members' strength and careful coordination. In the heat of combat, working in the confined, hot interior of the fighting compartment, this was exhausting. The rocket exhaust, even with the ventilation system, created noxious fumes that penetrated the fighting compartment. Crews were instructed to keep all hatches closed during firing to protect themselves from the blast and heat. After firing, they had to activate the ventilation system and wait for the fumes to clear before opening the breech for reloading. This process added to the reload time. The psychological strain was also considerable. Operating a vehicle that drew attention from every Allied aircraft in the area, knowing that your 68-ton vehicle could barely outrun a jogging infantryman if you needed to retreat, created constant stress. The Sturmtiger's low speed and poor maneuverability made it a sitting duck for air attack. The tactical employment of the Sturmtiger was hampered by doctrinal uncertainty. German commanders understood how to use conventional tanks and assault guns. They had years of experience and established tactical doctrines. But the Sturmtiger didn't fit existing categories. It wasn't a tank, lacking the turret and mobility for armoured warfare. It wasn't an assault gun in the traditional sense, as its weapon was too powerful and ammunition too scarce for the sustained fire support role. It wasn't artillery, despite the massive projectile, because its short range and limited ammunition capacity made it unsuitable for the artillery mission. The Sturmtiger was a siege weapon, designed for a specific tactical situation, the assault on fortified urban areas that rarely existed by the time the vehicle entered service. In defence, it could be effective, but only if positioned carefully, supplied with ammunition, and protected from air attack. These conditions were increasingly difficult to meet as Germany's situation deteriorated. Many Sturmtigers spent more time being transported to the rear for repairs or hidden from Allied aircraft than they spent in combat. The weapon's potential was undeniable, but potential matters little when it can't be realised in practice. Post-war analysis by Allied experts concluded that the Sturmtiger was an impressive piece of engineering, but a strategic dead end. British and American engineers who examined captured vehicles were struck by the quality of construction and the ingenuity of solutions to technical problems like venting the rocket exhaust. They recognised that mounting a 380mm rocket launcher on a mobile armoured platform was a significant achievement, but they also noted that the weapon filled no real need that couldn't be better met by other systems. Conventional artillery, while less dramatic, could deliver similar destructive effects with greater flexibility and sustainability. Air power could demolish buildings more efficiently and from longer range. The specialised nature of the Sturmtiger meant it was useful only in very specific situations, and building an armoured vehicle for such narrow circumstances was wasteful of resources. The Soviet evaluators who examined captured Sturmtigers came to similar conclusions. Soviet doctrine emphasised mass and simplicity. They had no interest in producing small numbers of super-heavy specialised vehicles. The T-34 and later T-44 represented their approach, good enough vehicles produced in overwhelming numbers. One Sturmtiger might be more powerful than a T-34, but 68 tons of a Sturmtiger could build 4 or 5 T-34s. Which was the better investment? For the Soviets, the answer was obvious. None of the Allied powers attempted to copy or even emulate the Sturmtiger concept, a clear indication of how they viewed its utility. The Sturmtiger's place in military history is as a fascinating footnote, an example of how engineering excellence can create impressive weapons that contribute nothing to victory. It stands alongside other German late-war superweapons like the Haus Super Heavy Tank, the V3 cannon, and various other projects that consumed resources while delivering negligible results. These weapons shared common characteristics. They were technically impressive, sometimes brilliant in their engineering. They were expensive and complex to produce. They required substantial logistical support. They were built in tiny numbers, and they had no meaningful impact on the war's outcome. The Sturmtiger demonstrates what happens when weapons development becomes divorced from strategic reality. Germany in 1944 and 1945 needed reliability, simplicity, and quantity. Instead, they produced complexity, specialization, and scarcity. The 19 Sturmtigers built during the war consumed resources that could have produced perhaps 100 conventional assault guns or tank destroyers, weapons that would have been more useful in the desperate defensive battles Germany was fighting. The legacy of the Sturmtiger in popular culture has been disproportionate to its actual military significance. The vehicle appears regularly in books, documentaries, and video games about World War II. Its distinctive appearance, with the short, stubby rocket launcher surrounded by exhaust ports, makes it instantly recognizable. The sheer audacity of mounting a submarine weapon on a tank chassis appeals to military history enthusiasts. But this popular fascination obscures the historical reality. The Sturmtiger was a failure, not because it didn't work as designed, it did, but because it was the wrong weapon for the wrong war at the wrong time. The 18 production vehicles and one prototype that were built saw limited combat, achieved modest results, and were ultimately abandoned or captured. None survived the war in German hands. The weapon they carried, capable of firing shells the size of torpedoes, represented the final expression of a philosophy that emphasized individual weapon power over systemic capability, technical excellence over strategic effectiveness, and engineering achievement over practical utility. It was, in many ways, the perfect symbol of late-war German armaments production, a triumph of engineering that was also a monument to strategic bankruptcy. The two survivors, at Kubinka and Munster, allow modern visitors to appreciate the scale and ambition of the design. Standing before a Sturmtiger, looking at the massive 380mm launcher, it's easy to imagine the destructive power of this weapon. The projectiles it fired could demolish buildings that had stood for centuries. They could destroy multiple tanks with a single shot. They created blast effects that terrorized enemy forces, but they couldn't change the outcome of a war that was already lost when the first Sturmtiger rolled off the production line. The weapon was obsolete before it was born, not because of any design flaw, but because the strategic situation had moved beyond the point where such weapons could matter. Germany needed a miracle in 1944. The Sturmtiger, impressive as it was not that miracle. It was an engineering marvel deployed in support of a lost cause, a weapon that arrived too late, in too few numbers, with too little ammunition to make any difference. The story of the Sturmtiger is ultimately a story about the futility of attempting to achieve through technology what cannot be achieved through strategy, about the limitations of engineering excellence when divorced from strategic reality, and about how the most powerful weapons are meaningless if there's no viable plan for victory. The tactical doctrine for employing the Sturmtiger was developed largely through trial and error during the Warsaw Uprising. The lessons learned there shaped how the weapon would be used for the remainder of the war. The primary tactical principle was standoff engagement. The Sturmtiger was never intended to charge forward with assault troops. Its slow speed and poor maneuverability made it vulnerable in fluid combat situations. Instead, doctrine called for positioning the vehicle in a secure rear area, typically 1,000 to 3,000 meters from the target, where it could fire its massive projectiles with reasonable accuracy while remaining protected from direct infantry assault. The crew would identify targets through reconnaissance, either by forward observers or by the commander's direct observation. Once a target was selected, typically a fortified building, bunker, or concentration of enemy forces, the vehicle would maneuver to a firing position. This process was time-consuming. The Sturmtiger's poor cross-country mobility meant it often had to use roads, making it vulnerable to ambush or air attack during movement. Firing procedures were elaborate. The gunner would align the weapon using the optical sight, calculating range and elevation. Given the projectile's ballistic characteristics, precision shooting beyond 2,000 meters was extremely difficult. The rocket motor provided additional velocity after launch, but this also introduced variables that affected accuracy. Wind, temperature, and even the age of the propellant in the rocket motor could influence trajectory. Once aligned, the commander would give the fire command. The gunner would activate the firing mechanism. A conventional propellant charge would first accelerate the projectile out of the barrel, followed milliseconds later by the ignition of the rocket motor. The blast from the muzzle was tremendous. Witnesses described a massive corona of flame erupting from the exhaust ports surrounding the barrel, followed by a thunderous roar as the rocket motor ignited. The projectile would streak toward its target, trailing fire and smoke, the distinctive exhaust pattern from the 32 nozzles at its base creating a spiral trail visible for kilometers. The sound was equally distinctive, a rushing roar that was completely unlike conventional artillery. Impact effects varied depending on the warhead, type and target. Against buildings, the high-explosive projectile was devastatingly effective. A direct hit on a multi-story structure would typically cause complete collapse. The 125-kilogram explosive charge, roughly equivalent to a 250-pound aerial bomb but delivered with far greater precision, would blast through walls and detonate inside, creating overpressure that blew out windows, collapsed floors, and brought down the entire structure. Survivors inside had virtually no chance. The blast wave alone, traveling through the building at supersonic speed, would kill or incapacitate anyone in the impact zone. Against reinforced concrete fortifications, the shaped charge projectile was used. The hollow charge effect focused the explosive energy into a superheated jet of metal and gas traveling at over 8,000 meters per second. This jet could penetrate 200 meters of steel-reinforced concrete, more than sufficient to defeat any bunker or fortification the Allies had constructed. Once inside, the jet would continue through the interior, killing occupants and igniting ammunition or fuel. Even bunkers that weren't completely penetrated would often be rendered uninhabitable by the shock and spalling. Fragments of concrete blown off the interior walls at high velocity that acted like shrapnel. The psychological effects were often as important as the physical destruction. Troops who had experienced conventional artillery fire, who had learned to take cover and wait out barrages, found the Sturmtiger uniquely terrifying. The massive explosions, the seemingly arbitrary destruction of entire buildings with single shots, and the distinctive sound of the approaching projectiles created panic. German after-action reports from Warsaw noted that Polish resistance fighters would often abandon positions simply upon learning a Sturmtiger was in the area, even before it had fired. This psychological impact was multiplied by uncertainty. Because the weapon was unknown to Allied intelligence throughout most of 1944. Troops being bombarded by Sturmtigers didn't know what was hitting them. Reports variously attributed the explosions to railway guns, aerial bombs, or some new type of rocket artillery. The mystery added to the fear. It's one thing to know you're being hit by conventional artillery, you understand the weapon and its limitations. It's another to be hit by something unknown and seemingly unstoppable. The ammunition supply situation crippled the Sturmtiger's operational effectiveness more than any tactical limitation. With only 317 projectiles produced during the entire war, even the limited number of vehicles in service couldn't be kept supplied. Each Sturmtiger carried 14 rounds internally. If a company of 4 vehicles was fully loaded, that represented 56 projectiles, nearly 18% of total production. Fire all those rounds in combat, and resupply became problematic. The projectiles were manufactured at limited facilities and required specialized components, particularly the rocket motors and their solid propellant. Production was further hampered by Allied bombing. The facilities producing the projectiles were vulnerable to air attack, as were the transportation networks needed to move completed rounds to units in the field. Several shipments of Sturmtiger ammunition were destroyed en route by Allied fighter bombers, further reducing the already inadequate supply. This ammunition scarcity forced crews to use their rounds sparingly, often holding fire even when targets were available, simply because they couldn't be sure of resupply. This undermined the weapon's tactical effectiveness. A weapon that can only fire a few times before becoming useless is of limited value, regardless of how powerful each shot might be. Commanders learned to hoard their Sturmtiger ammunition for critical situations, but this meant the weapons often sat idle during battles where they might have been useful. The psychological impact of this was significant. Crews became frustrated, knowing they possessed tremendous firepower, but couldn't use it freely. The few rounds they did fire had to count, adding pressure to already stressful combat situations. Missing a shot wasn't just a tactical failure, it was a waste of an irreplaceable resource. The mechanical reliability issues that plagued all German heavy tanks were magnified in the Sturmtiger. The Tigerwood chassis, while relatively robust by German standards, was maintenance-intensive even in its original configuration. Adding 11 tons of weight in the Sturmtiger conversion, stressed every component beyond its design limits. The transmission, already a weak point in the Tiger I, was particularly problematic. The Maybach Olva 14-6B transmission was designed for a 57-ton vehicle. At 68 tons, the Sturmtiger exceeded this by nearly 20%. Gear failures were common, especially when the vehicle had to maneuver on slopes or in soft ground. The final drives, which transferred power from the transmission to the drive sprockets, were similarly overstressed. These components had a tendency to fail after relatively limited mileage, sometimes as little as 500 kilometers. Replacing a final drive in the field was nearly impossible, requiring specialized tools and facilities. Most Sturmtigers that suffered final drive failure were simply abandoned. The engine, while powerful, was operating at the limit of its capability. The Maybach HL230 P45 had been designed to power the Panther tank, which weighed around 45 tons. In the Tiger at 57 tons, it was already working hard. In the Sturmtiger at 68 tons, it was constantly stressed. Overheating was common, especially in summer or during prolonged operations. The cooling system, adequate for the Tiger I, struggled to dissipate the additional heat generated by the engine, working under constant heavy load. Engine failures were frequent, requiring complex repairs that field maintenance units often couldn't perform. The fuel consumption was staggering and became catastrophic as Germany's fuel situation collapsed in late 1944 and early 1945. The Sturmtiger consumed approximately 1,000 litres per 100 kilometres under normal conditions. In combat, with frequent manoeuvring and the engine working at high power settings, consumption could reach 1,500 litres per 100 kilometres. To put this in perspective, moving a Sturmtiger just 100 kilometres required as much fuel as would power a Volkswagen Kübelwagen for 2,000 kilometres. By early 1945, Germany's fuel production had collapsed under Allied bombing. Synthetic fuel plants were priority targets for Allied strategic bombing, and by February 1945, production was less than 10% of 1944 levels. What little fuel was available went to defending fighters trying to stop Allied bombing raids. Armoured units received minimal allocations. This fuel shortage meant that Sturmtigers often couldn't reach the battlefield. Units would receive orders to move to a combat zone, only to find they had insufficient fuel to make the journey. Vehicles would be loaded on rail cars, but rail movement was increasingly difficult as Allied air power destroyed locomotives and tracks. The result was that Sturmtigers spent much of their operational life stationary, waiting for fuel that never came, or abandoned alongside roads when they ran dry. Several vehicles were lost this way, never having fired a shot in combat. The crews would drain the fuel tanks, remove sensitive equipment and documents, and destroy what they could before retreating on foot. Allied forces would find these massive vehicles abandoned in forests or villages, out of fuel and out of war. The training of Sturmtiger crews was abbreviated by necessity. By 1944, Germany had neither the time nor resources for extended training programs. Crews were typically drawn from existing assault gun or tank units, and given basic familiarization with the vehicle and weapon. This consisted of perhaps a week of instruction on vehicle operation, weapon loading procedures, and firing characteristics. Live-fire training was almost non-existent given the ammunition shortage. Most crews fired their first Sturmtiger projectile in combat. This lack of training showed in combat effectiveness. Gunners struggled with the unusual ballistic characteristics of the rocket-propelled projectiles. Unlike conventional artillery shells, which followed predictable trajectories, the Sturmtiger projectiles were subject to variables that affected accuracy unpredictably. The rocket motor added velocity after launch, but ignition timing could vary slightly between rounds. Wind had greater effect on the large projectile than on conventional shells. Temperature affected the propellant burn rate. All these factors made precision fire difficult, and without training rounds to practice, gunners had to learn through combat experience. By the time a crew became proficient, they often had no ammunition left, or the vehicle had broken down, or the tactical situation had changed and they were retreating. The few crews that managed to remain operational for months became quite skilled, developing an intuitive understanding of the weapon's characteristics. But these experienced crews were rare. Most Sturmtiger crews had limited combat experience before their vehicle was lost or abandoned. The command and control of Sturmtiger units was complicated by their unique capabilities and limitations. Corps and army commanders who had Sturmtiger companies attached to their forces often didn't understand how to employ them effectively. Some commanders tried to use them as conventional assault guns, expecting them to advance with infantry and provide direct fire support. This invariably ended badly, with the slow-moving Sturmtigers unable to keep up with attacks and becoming isolated. Other commanders positioned them too far to the rear, where their limited range made them ineffective. The weapons could reach out to 5,000 metres, but effective fire beyond 2,000 metres was difficult without forward observers, and German forces increasingly lacked the communications infrastructure for effective fire coordination. The ideal employment, as demonstrated at Warsaw, required careful planning and reconnaissance. Targets had to be identified in advance. The Sturmtiger had to be positioned where it could engage these targets while remaining protected. Fire missions had to be coordinated with other forces to ensure the massive explosions didn't endanger friendly troops. And all of this had to happen while accounting for the vehicle's limited ammunition, poor mobility, and mechanical fragility. Few German commanders in late 1944 and 1945 had the luxury of such careful planning. The front was collapsing, communications were breaking down, and immediate tactical needs overrode doctrinal employment. The Allied response to the Sturmtiger evolved as awareness of the weapon grew. Initially, when the massive explosions were first encountered at Warsaw, Allied intelligence had no idea what weapon was creating them. The projectiles were unlike anything in known German arsenals. Reports were confused and contradictory. Some attributed the blast to aerial bombs, though no aircraft were observed. Others suggested railway guns, but no rail-mounted artillery was identified in the area. It wasn't until early 1945, when the first Sturmtigers were captured, that Allied intelligence confirmed the weapon's existence and capabilities. Once identified, the response was primarily to target the vehicles with air power. The Sturmtiger's slow speed made it vulnerable to fighter-bomber attack, and its large size made it easy to spot. Allied tactical air forces began specifically hunting for Sturmtigers when their presence was reported. The vehicles had to be carefully camouflaged and hidden when not in use, limiting their operational flexibility. Several Sturmtigers were destroyed or damaged by air attack while, moving between positions, artillery was less effective against the heavily armoured vehicles. The 150mm frontal armour, angled at 47 degrees, could resist most artillery shells except for direct hits from heavy guns at close range. The Allies possessed such weapons, particularly their heavy anti-aircraft guns used in ground roll, but getting them into position to engage a Sturmtiger was difficult. The vehicles could fire from standoff range, remaining beyond the effective reach of most anti-tank guns. Infantry found the Sturmtigers nearly impossible to engage effectively. The heavy armour resisted anti-tank rockets and shaped charges that would disable lighter vehicles. The close defence weapon system made infantry approach extremely dangerous. Attempting to assault a Sturmtiger with infantry was suicidal, unless the vehicle was already immobilised or out of ammunition. The most effective Allied counter was simply to avoid areas where Sturmtigers were operating. Units would bypass strong points defended by the vehicles rather than assault them directly. This tactical flexibility, possible because Allied forces had the initiative by late 1944, meant the Sturmtigers often found themselves defending empty sectors while the Allies advanced elsewhere. The weapons were too slow to reposition quickly, and fuel shortages meant they often couldn't relocate even if ordered to do so. The crew experience inside a Sturmtiger during combat was unique and harrowing. The fighting compartment, while larger than most German armoured vehicles, was still cramped with 5 men, 14 massive projectiles, and all the associated equipment. When the weapon fired, despite the exhaust venting system, crews experienced tremendous noise and vibration. The vehicle would rock back on its suspension from the recoil, despite the relatively gentle acceleration of the rocket launch compared to conventional guns. The blast from the exhaust ports, even directed forward, created pressure waves that buffeted the vehicle. Inside, the crew would feel the deck plates shudder and hear the thunder of the discharge even through their headsets and the vehicle's armoured hull. After firing, the crew had to immediately begin the reload process. This required precise coordination. The loader and assistant loader would manhandle the next projectile from storage onto the loading tray, a process that required strength and care. The projectile weighed as much as both men combined and had to be lifted, positioned, and secured without damaging the fragile fins or rocket nozzles. Once on the tray, the projectile would be rolled forward to the breech. The breech block would be opened, the round pushed into the chamber, and the breech closed and locked. This entire process, under ideal conditions with a trained crew, took about 3 to 4 minutes. In combat, with the vehicle possibly under fire, with crew members fatigued or wounded, reload times could stretch to 5 minutes or longer. During this reload period, the Sturmtiger was essentially defenseless. The main weapon was empty. The single machine gun provided minimal protection. If enemy infantry approached during reload, the crew's options were limited. They could attempt to complete the reload and fire, but this took time. They could close all hatches and rely on the armor for protection, but this left them blind and vulnerable. Or they could abandon the vehicle, but this meant leaving an extremely valuable and powerful weapon to the enemy. Most crews chose to try to complete the reload, trusting their armor to protect them. This worked against small arms and light weapons, but made them vulnerable to anti-tank weapons or close assault by determined infantry. The psychological pressure of reloading while under fire, knowing you were vulnerable, knowing that your massive armoured vehicle was temporarily helpless, was immense. Crew accounts mention the relief when the breach finally closed on a fresh round, and they could fire again, even if just to clear the immediate area of threat. The view from inside the vehicle was extremely limited. The commander had a cupola with vision blocks, but these provided only narrow fields of view. The gunner had his optical sight, but this was focused on aiming, not situational awareness. The other crew members had essentially no external vision except through the few pistol ports. This meant the crew was often unaware of what was happening around them, unless the commander kept up a constant commentary, and in the chaos of combat this was difficult. The sound environment inside was overwhelming. The Maybach engine located in the rear of the vehicle created constant noise even at idle. At full power, the engine's roar made verbal communication difficult even with the intercom system. The transmission and final drives added their own mechanical sounds, whines and clatters that indicated whether the components were operating normally or developing problems. When the weapon fired, the noise was indescribable. Despite the crew wearing protective equipment, the blast was stunning. Many crew members suffered hearing damage after extended operations. Between firings, the crew could hear impacts on the armor, enemy fire striking the vehicle. Small arms and machine gun rounds created a distinctive pinging sound, usually ignored as they couldn't penetrate. Anti-tank rounds created a different sound, a sharp crack followed by ringing as the armor absorbed the impact. Crew members learned to distinguish between rounds that had been defeated by the armor and those that might have penetrated or caused spalling. A hit that created showering sparks or fragments inside the compartment meant damage, possible injury, and potential catastrophe if ammunition or fuel was struck. The temperature inside varied wildly. In cold weather, the uninsulated steel interior was freezing, especially before the engine warmed up. Crew members wore heavy winter gear but still suffered from cold during extended operations. In warm weather, the opposite was true. The engine generated tremendous heat, and with ammunition and 5 bodies in a confined space, temperatures could become unbearable. The rocket exhaust, even with venting, added heat during and after firing. Crews would emerge from their vehicles after combat soaked in sweat, exhausted not just from the stress of battle, but from the physical demands of operating in that environment. The smell inside was equally unpleasant. Unwashed bodies, oil and fuel fumes, the acrid smell of rocket exhaust that permeated everything despite the ventilation system, cordite from the propellant charges, and the metallic tang of fear. Crews couldn't maintain cleanliness in combat conditions. They ate, slept, and fought in that confined space, sometimes for days without leaving the vehicle. The experience was physically and mentally exhausting in ways that are difficult for those who haven't experienced it to understand. The fate of individual Sturmtigers can be traced through available records, though many details remain unclear. Vehicle number 2503-1 was lost at Remagen, captured by American forces and subsequently scrapped. Number 2543 was lost in the Rhineland fighting, abandoned due to mechanical failure, and later destroyed by its crew. Number 2574 survived the war, and now resides at the Deutsches Panzermuseum. The specific combat history of this vehicle is unclear, but it was captured by American forces somewhere in western Germany in April 1945. Number 2588 and 25 200 saw action in the Warsaw Uprising and possibly later fighting. Their ultimate fates are not definitively recorded. Several vehicles have only chassis numbers preserved in records, their individual histories lost. This lack of detailed records reflects the chaotic final months of the war, when record-keeping collapsed and vehicles were lost faster than their fates could be documented. The men who crewed these vehicles came from various backgrounds. Some were experienced tankers, veterans of campaigns in Russia or North Africa, who had transferred to assault gun units. Others were younger soldiers, trained in the abbreviated programs of 1944 and 1945. A few accounts from these crew members survived the war. They speak of the mixed feelings they had about their weapon. Pride in operating something so powerful and unique, frustration with the mechanical problems and ammunition shortages, fear of air attack, which they were nearly defenseless against, and a growing sense of futility as the war ground toward its inevitable conclusion. One anonymous crew member, interviewed by American intelligence in May 1945, summed up the experience by saying that the Sturmtiger was the most powerful weapon he had ever operated, and also the most useless. Powerful because a single shot could destroy anything, useless because there were never enough shots, never enough fuel, never enough time to use it properly. The impact of the Sturmtiger on German military effectiveness was negligible in strategic terms, but occasionally significant at tactical level. At Warsaw, the weapons contributed to the suppression of the uprising by demolishing key resistance strongpoints. At Remagen, they destroyed American armour and disrupted operations around the bridgehead, though they failed in their primary mission of destroying the bridge itself. In various defensive actions in the West, they broke up Allied attacks and caused casualties. But none of this changed the outcome of battles, let alone campaigns. The war was decided by factors far beyond what 18 assault guns could influence. Industrial capacity, manpower reserves, fuel supplies, air superiority, these were the elements that determined victory and defeat. The Sturmtiger, for all its awesome firepower, was irrelevant to these decisive factors. It could destroy buildings and kill soldiers, but it couldn't produce fuel, it couldn't replace losses, and it couldn't challenge Allied air supremacy. The weapon was a curiosity, an interesting technical achievement that highlighted how Germany's priorities had become disconnected from military reality. The post-war assessment by military historians has been consistently negative regarding the Sturmtiger's strategic value. Most analysis concludes that the resources consumed in developing, producing and supporting these 19 vehicles would have been better spent on almost anything else. More conventional assault guns, more ammunition for existing weapons, more trucks for logistics, more fuel for operations. Literally any alternative use of those resources would have contributed more to Germany's war effort. The Sturmtiger is often cited as an example of the German obsession with superweapons and technical perfection that undermined their ability to wage total war effectively. While the Allies focused on mass production of good enough equipment, Germany pursued technical excellence in small quantities, a strategy that guaranteed defeat once the material balance shifted decisively against them. The Sturmtiger embodies this flawed approach. It was an excellent solution to a problem Germany no longer faced, built with resources Germany couldn't spare, deployed in numbers too small to matter. Yet the weapon retains its fascination decades after the war ended. The image of a Tiger tank chassis topped with a massive rocket launcher, firing projectiles the size of torpedoes, captures the imagination. It represents the audacity of German engineering, the willingness to attempt things other nations considered impossible or impractical. In this sense, the Sturmtiger is emblematic of both the strengths and fatal weaknesses of German military technology. The strengths were real. The weapon worked as designed, delivering tremendous destructive power in a mobile armoured package. The engineering was sophisticated, solving complex problems like venting rocket exhaust and loading enormous projectiles in a combat vehicle. But the weaknesses were equally real and ultimately fatal. The complexity made reliability poor. The specialization made it useful only in narrow circumstances. The small production run meant it could never achieve strategic impact, and the resources it consumed were resources Germany desperately needed elsewhere. The Sturmtiger stands as a monument to German engineering achievement and strategic failure, a weapon that worked perfectly while contributing nothing to victory, a symbol of how technical excellence cannot compensate for strategic bankruptcy. It fired shells the size of torpedoes from a tank chassis, an achievement no other nation attempted during World War II. But this achievement, impressive as it was, changed nothing. The 19 Sturmtigers built could not alter the outcome of a war that was already decided. They could demolish buildings, destroy tanks, and terrorize enemy forces, but they could not produce fuel, replace losses, or challenge the overwhelming material superiority of the Allies. In the end, the Sturmtiger was a magnificent irrelevance, a weapon that demonstrated both the heights of German engineering and the depths of German strategic confusion in the final years of the Third Reich.